Welcome back to Math. This is Section 10 on word problems. We'll talk first about understanding the story, and then about three familiar patterns. First, the chronological story with a start, event, and a finish. Second, a relationship to apply. And third, a formula to use or to create and use. And then we'll talk about keywords. Word problems connect math to the real-world relevance. Math exists to solve our daily problems, but we often get too caught up in the doing of math to make the connection. To solve a problem, we have to determine what facts we know and what facts we need to find. So first, we just need to read and understand the problem. The first time you read it, ignore the numbers. If I read this problem first with the numbers, here is what it sounds like. Sally's house has 1,200 square feet of walls to be painted. She has already painted 800 square feet. How much still needs to be painted? Did you hear that problem and begin to worry about how to calculate square feet? That might be natural, but it isn't what we need to solve. So let's listen to the problem again this way, ignoring the numbers. Sally's house has some walls to be painted. She has already painted some. How much still needs to be painted? That's the same word problem using the word some to replace the quantities in the detail. Now it's simpler to know what we need to solve. There will be a list of keywords later, but you probably already realized that we just need to subtract the amount already painted from the total to find what's left to paint. The math is 1,200 minus 800 equals 400, and the answer is 400 square feet. The more word problems you practice, the faster you will get. That's because you will begin to do some of the following steps at the same time. But if word problems are new or still challenging for you, try to follow these steps one at a time. First, read the problem without quantities to understand the story. Second, does the story fit a familiar pattern? Determine what detail you're asked to find and assign a variable. Organize the information you're given, solve the problem, and finally ask yourself, does that answer make sense? A lot of word problems fit into one of three categories. The first one is a chronological story with a start, an event, and a finish. The story isn't always told in chronological order. You might be told the start and the finish and need to find out what happened in the middle. You can recognize this type of word problem because it usually sounds the most like a story, with a series of events and a beginning, a middle, and an end. The example we just talked about in the previous section with Sally painting her house is this type of a problem. At the start, there were 1,200 square feet to paint. In the middle, an event occurred when she painted 800 square feet. So at the end of the story, there were still 400 square feet to paint. You can organize this type of a problem by writing start, event, and finish. Then line up the information you're given in chronological order with these words. Once you do that, you can use your understanding of the story to fill in the math operations that make an equation. So, start, 1,200 to paint. Event, 800 painted. And that equals some sort of finish. Well, that's a difference. 1,200 minus 800 equals 400. Here's another example. Joe needed to buy some school supplies. He bought a pack of 12 pencils for $1.59, a backpack for $19.99, and 3 notebooks that were $2.99 each. He had $19.45 left. How much money did he start with? Well, first let's read that without the numbers. Joe needed to buy school supplies. He bought some stuff, then he had some money left. How much did he start with? So how much did he start with? That's what we're looking for. And usually what we're looking for is the variable that we're going to assign. So we'll call it X, maybe even X dollars. Then there was an event where he bought some stuff. He bought 12 pencils for $1.59 and plus He bought a backpack for $19.99 and plus 3 notebooks that were $2.99 each. So that's 3 notebooks times $2.99. And at the finish, he had $19.45 left. So you know how this is going to go. The start minus what he bought is going to equal the finish. All right, let's do some of the math here. He actually spent $30.55. So x minus $30.55 equals $19.45. We need to add $30.55 to both sides of the equation because that's what's being taken away from x. And we do that, we get x equals $50. The second common type of word problem that we'll talk about is a relationship. These problems describe a proportional relationship which is likely to contain the word per. You need to figure out which two items have a relationship and apply that relationship to another example. Let's look at this. Joe makes $15 per hour. How much does he earn in an 8-hour shift? So if we figure out what the relationship is, and we write it in a fraction format, dollars and hours. He gets $15 per 1 hour. So we keep the dollars in the numerator and the hours in the denominator. We do that all the way through. How much does he earn? That's dollars. That's what we're looking for. That's x, the unknown, in an 8-hour shift. 8 hours is on the bottom. We cross multiply and we get $120. Section 7 covered a whole bunch of these kinds of proportion and ratio problems if you want to go back and review these. The third main type of word problems that we'll talk about involves a formula. It may be a known formula, like the volume of a cylinder, or it might be a formula that you have to derive from the story. David's rectangular garden is 5 feet by 10 feet. What is the area of his garden in square feet? There's a known formula for the area of a rectangle. You need to be familiar enough with the common formulas to know it, or be able to look it up if you're allowed to. It is area equals base times height. There might be a picture, or you can even draw a picture, because that often helps. So his garden is 5 feet by 10 feet. That's the base, and that's the height. So first we've written the formula. Next we need to organize the data that we're given and substitute it into this formula. In this case, area, that's what we're looking for, equals the base, 10 feet, by the height, 5 feet. So the area equals 50, and it would be square feet. Here's another example, and this is an example where we need to come up with our own formula to solve the problem. It says at the end of soccer tryouts, 20% of the children who tried out were chosen for the team. If 15 were chosen, how many tried out? So we already know how many children were chosen. We're looking for how many were tried out. So let's assign a variable that stands for the number of children who tried out. So we'll say let x equal number of children who tried out. Now we'll write down what else we know. 20% of the children were chosen. So 20% of x chosen. We also know that 15 were chosen. Well, if these two are the same thing in math, we use an equal sign. So let's get this combined and written out. And remember that of is a keyword that almost always means to multiply. So 20%, I'm going to write that as a decimal, of x times x, in other words, is the same as 15. Now we just need to divide each side by 0.20, or 2/10, 20%, in order to get the answer that x equals 75. Even when a story seems complicated, we can usually translate it directly from English words to math words. Consider this problem. In 5 years, Jill will be 4 years less than 2 times her current age. How old is Jill? Even if you aren't very familiar yet with the keywords, you'll probably see phrases like less than and 2 times. So we know there's going to be some subtraction for less than and some multiplication for 2 times. We just need to get it in the right order. So the problem asks for how old is Jill. So that's almost always what we need to assign the variable to, is what they're asking us to find. So Jill's age now. Okay, in 5 years, well, that will be Jill's age now plus 5. Jill will be. Anytime there's any form of is, was, will be, that means an equal sign. And then it says 4 times less than 2 times her current age. That's 2 times her current age with 4 taken away from it. So put all together, here's our equation. We just need to solve now. We've got x on both sides. Let's take an x away from both sides. We'll get 5 equals x minus 4. Add 4 to both sides, and we'll get x equals 9. So Jill is 9 years old. Notice this phrase, 4 less than some number. We have to write that as x minus 4, not 4 minus x. We know that when we subtract, the number we subtract from gets listed first. And even though we know this, it's an easy mistake to make because we want to write the equation exactly as we say it. We just need to be careful not to write the first thing we hear, and again, a lot of experience and practice will make this easier. Below is a chart of some keywords and their likely meanings and problems. No list like this is ever going to be perfect or ever going to be complete, and there's no substitute for just reading and understanding the problem. And there's no substitute either for practice when it comes to solving word problems. This list of keywords is also in the instruction sheet that you can download. Also in that instruction sheet are some practice problems, so if you want to do those on your own, and then come back watch the next video and we'll solve them together.